I'm going to continue on explaining with dynamic programming. So how this dynamic programming concept works. I know everybody have this mindset is dynamic programming is completely working on recursion call tree. And so how a recursion works, we know, right? If you call with 5, then if you do something, then we'll go with 4 and then again 3 and again this 4 can again go with 3, 2 and 1 and like this, right? So a dynamic programming is generally done using recursion. That can be done two approaches. One is top down and one is bottom up also. Okay, there is a problem that is the stack depth risk is there. If you do top down bottom, but bottom up, no. The time complexity, as many of you are asking that, so time complexity and space complexity is there. Okay, so in recursion, this is space complexity of recursion stack. If it is normal bottom up, it's like this. Easier to write is this, but slider harder. Okay, now I will summarize that with both of the examples. That is with an example of you can see this one is I can do a bottom up. No, I'll first do for you. Yeah, here I have done. Okay, bottom up, you can just do this here first. So then we can do the other example. Okay, guys. So, or you can just see the first bottom up. That's better way. So if you see the bottom up approach, I was first line telling you all of you whether you prefer this approach of coding or that approach of coding. So many of you had this question in your mind. Venkatesh, can we do in this approach or that approach? Definitely, I'll share you this slide to you guys. So if you ask me if I mean someone here, a lot of smiling coders were there here. They were asking me this question, Venkatesh. You asked me now in the starting. I was telling you this question to all of you, right? So which approach of coding we have to follow in the real time? I just told you now, guys. DSA patterns. I told you here, right? So one second. I was just telling you here something interesting, right, for all of you. Somewhere I've written. Okay. So that this approach I was talking about, right? So where is this approach? Memory. So cool. So I wrote somewhere the code recursion. Okay. So I was telling you right at the starting in interview they were asking you whether this approach 2 is better or approach 1 was better. I think someone we had Pratik and a lot of people were asking that question, right? So I'm telling on that only, guys, for you that this approach 1 is you are calling inside this function another function. I mean, approach 1 is you are trying to do recursion based. Approach 2 is inside the loop you are trying to call another function. Now the same concept comes here, bottom up and other way. Bottom up means you write a function, you are trying to write a loop, and inside this you are appending some data to some list actually, but you are trying to do this approach. That is called bottom up. If you see in dynamic programming, the bottom up is not using recursion, but space is this, time is the same thing. But if you do top down, you will use recursion. So that is where, if I say this approach of coding, it doesn't consume more stack size, but you are appending the data to the new list only. Okay, this is bottom approach. So you can simulate this example. So mainly differences, you have to understand this concepts. Nobody is gonna ask you write the code and yeah, your congratulations, you got selected. Nobody is gonna do this, especially for someone who is beginner level at someone who has little experience level. Beginner level, they will see your code and your thinking behind it. But for someone most experienced, they will not ask you the code and solution. They will ask you, take the code and ask you this. I mean, from my experience, guys. Okay, so this is going to happen here. So it's going to do not recursion. It's normally happening. It's adding the values in the list of your list, right? And giving you final result. Okay, it's appending that and then doing that. But if you are working with the other approach, that is your dynamic programming, it is going to be recursion. So you can see that. So you are calling this fib memo, you are passing value 5. What happens here? It's a factorial approach of recursion. You pass 5 here, memo is none, depth is 0. So what happens in this case? So you are going to call the same function with n minus 1. It means what? 5 means 5 minus 1. So you're going to call with 4. And again, what will happen? But this is not going to be like this because you are doing one more recursion call. So that's diagram of mine is a smiling diagram. Okay, understand my smiling diagram. that my smiling diagram says you, if you are going to do like this, 5, that is fine. Here you're going to call with 4, and next recursive call will be done with 3. It means there is 2 recursive calls. 5 minus 1, 4, 5 minus 2, 3. I hope all of you clear there. And then we are talking about the other one. This guy will again go with 3 and 2, and again this guy will go 2 and 1. 3, because 3 wala will again go to that, and again this will go like this. So this is a recursive stack tree without memoization. So in this case, this is going to happen like this. So n minus 1 memo, then you are passing the same memo, and depth is 0 plus 1. This is 0 plus 1. That's the computation is going to happen with the recursion approach. So with the recursion approach, how the computation happens. So it sees you get like this. See here. So first fib5 was called, then fib4 was called, then fib3 was called, then again 2 was called, again 1 was called. When 1 actually was called, that time 0 will come, 1 minus 0. That time the recursion stop happens. So the base with 0 will happen. Then again 1, 2, 3, 4 will again end. But again, there's a computation that will be done for again other way of it. That for that other way of it, it's been showing you the thing, the base of it. Okay. And this is how the whole dynamic programming, if you're going to work with dynamic programming, that's the progress that you do with the dynamic programming. Okay. So this is a whole idea you can do with the dynamic program. So when now I'm coming to the conclusion stage, I would able to help you to master some of these patterns here. As a smiling coders, all sliding window pattern, you are working with linear search, you are working with fixed variables windows. Okay. Efficiently handling continuous subarrays. 2 pointers, you are working with linear search plus sorting. You traverse from both ends to solve the problems. Fast and slow pointers, you are doing a linear scan and pointer speed logic. I am telling you all this is the purpose, but purpose and when to use, that is outcome. The outcome is very important. So you need to know the pattern, and the pattern will give you what outcome. Okay. Divide and conquer pattern uses recursion, and dynamic programming uses recursion and memoization. Okay. And dynamic program bottom up also we use this. Okay. And divide and conquer. So recursion and subproblem. And here we use linear scan. So that is how your excitement should be. And you are excited to join us, you can lock your spot on, you can register here also. So we can help you all the smiling coders here in terms of your Python placement with a great mentorship and placement assistance from the industry expert. There is no catches here. If you want to register, you can register, because this is something we can as a mentoring process to mentor you and handhold you to get a new opportunity. We are always there with you, smiling coders, as a CoderRange community. And today we are having a successful announcement. We have reached a milestone of 11,000 members closely. And I mean, it's all because of your kind of, learning motivation, and the community is always spreading the learning across, Bangalore and across everywhere. And that's all because of that. Today we are spreading, a big community that we are actually heading here.